In this video, we're going to look at another application of finding the volume of revolution by applying the washer method. The question here is to find the volume of the solid obtained by rotating the region bounded by the curves y equals arctan x, y equals pi over 4, x equals 0, rotated about the line x equals negative 2. As usual, we will find the points of intersection first. So we have y is equal to tan minus 1x, and we have y is equal to pi over 4. We make y equals y, we get tan minus 1x is equal to pi over 4. And now to solve for x, we'll take tangent of both sides. So we get tangent of tan minus 1x is equal to tangent of pi over 4. Tangent and inverse tan cancel out, and we get x. X is equal to tangent of pi over 4. We can apply the 45, 45, 90 triangle, and tangent of pi over 4 is equal to 1. Y is equal to pi over 4, because we started with y equals pi over 4. All right, now let's look at y equals tan minus 1x and x equals 0. So plug in x equals 0 here, and we get y is equal to tan minus 1 of 0. What is arctan of 0? Well, this is saying what is the angle whose tangent is 0? Well, tangent of 0 is 0, so the answer is 0. So we have x equals 0, y equals 0. So let's summarize. We have the intersection points x equals 1, y equals pi over 4. We also have the intersection point x equals 0, y equals 0, and it's very important to determine the points of intersection so we know the values over which we will integrate. In this case, it will be the y values that will be integrated. All right, so now let's also draw this the special triangle that we applied, the 1, 1, root 2. So here's the 1, 1, root 2 triangle, and the angle is 45, that's pi over 4, pi over 4. Tangent of pi over 4 is opposite over adjacent, that's just 1. All right, so now let's look at sketching the bounded region and a typical washer. So here we have the graph of arctan x. The graph of arctan x has horizontal asymptote y equals pi over 2 and y equals minus pi over 2. And also, the most important part here is to define the outer radius and the inner radius. The outer radius is a distance from the axis of rotation, which is x equals negative 2, to the farthest point on a slice that we've drawn. So basically, it's this distance here. The radius outer is going to be tan y minus 2. So we look at the x value corresponding to the tangent function, that's x equals tan y, and subtract minus 2. So it's going to be tan y minus 2, we get tan y plus 2. And it's very important to have the right construct here. It has to be minus minus, because you're subtracting two values. The inner radius is a distance from the axis of rotation to the closest point on the rectangular slice that we've drawn. So it's this distance here. The distance from x equals 0 to x equals negative 2. So 0 minus 2 is equal to 2. That is the inner radius. And we've drawn a typical slice here. The radius inner is 2, and radius outer is this larger radius is tangent y plus 2. Very important that you have the right radius of revolution, radius of rotation. Otherwise, everything after that will be wrong. So make sure that you take the time to analyze it and make sure that it makes sense. So again, the outer radius is a distance from the axis of rotation, which is x equals negative 2, to the farthest point on your slice. It's this distance here. So it's the x value corresponding to the tangent function. If you solve for x in terms of y, we get x equals tan y. So it's going to be tangent y minus 2 gives us the outer radius of rotation, and the inner radius is a distance from x equals negative 2 to x equals 0. So, and that's 0 minus 2, that gives us 2. All right, so now we have to, let's summarize everything that we've done. So we have radius outer is equal to tangent y plus 2. Radius inner is equal to 2. The cross-sectional area is the outer radius squared minus the inner radius squared times pi. So it's pi times outer radius squared, that's tangent y, plus 2, all squared, minus the inner radius, which is 2, all squared. And the washer volume is going to be differential volume is pi times tangent y plus 2 all squared minus 2 squared dy. The total volume of the solid is volume is equal to pi integral from 0 to pi over 4 tan y plus 2 all squared minus 2 squared integrated with respect to y. So these are y values. Y equals 0, y equals pi over 4. All right, now the hard part is to integrate this, and we're going to use trig identity. 1 plus tan squared y is equal to secant squared y. So we'll keep that in mind when we solve this integral. All right, so we want to set up a definite integral and find the volume. So here it is. This is radius outer squared minus radius inner squared times pi. And now we're going to expand this. So we get volume is equal to pi. Integral from 0 to pi over 4. Let's FOIL out tan y plus 2. So we get tan squared y. Squaring tan y plus 2, tan squared y. Plus 2 times tan y times 2. So we just get 4 tan y. Plus 2 squared, that's just 4. Minus 2 squared, that's 4. And if we simplify, 4 and 4 cancel out, 4 minus 4. So volume is equal to pi, integral from 0 to pi over 4, tan squared y, plus 4 tan y. All right, so now let's split up the integrals and integrate term by term. So pi times integral from 0 to pi over 4 tan squared y dy plus pi times 4, we get 4 pi. 4 is a constant, passes through the integral. We're splitting up the integrals and doing them piece by piece. 0 to pi over 4 tangent y dy. All right, so what we have is volume is equal to pi integral from 0 to pi over 4 tan squared y dy plus 4 pi integral from 0 to pi over 4 tangent y dy. We're going to use a trig identity. Tan squared y is secant squared y minus 1. Tan squared y is equal to secant squared y minus 1. Volume is equal to pi integral from 0 to pi over 4 secant squared y minus 1 dy plus 4 pi. We're going to apply the U substitution technique here. We're going to write tangent y as sine y over cos y. So integrate from 0 to pi over 4, and we have sine y over cosine y dy. So we're going to let u be equal to cosine y, the denominator. Its derivative will give us the numerator. Du is a constant multiple of the numerator. Du is minus sine y dy. Let me write this properly, dy. And so now the integration, volume is equal to pi. What is the antiderivative of secant squared y? That's just tangent y, because derivative of tan y is secant squared y. What is the antiderivative of 1? That's just y. Evaluated from 0 to pi over 4 plus 4 pi. And the integral of sine y over cos y with respect to y is just going to be minus log of cosine y if we apply the U substitution technique from 0 to pi over 4. I've left out some of the steps of the U substitution, but you should be able to do that. That's quite easy. So volume is equal to pi times, put the upper limit in, we get tangent pi over 4, applying fundamental theorem of calculus, minus pi over 4, minus, put the lower limit in, we get tangent 0, minus 0, close bracket, another close, and then plus, minus 4 pi. Let's combine this minus with a 4 pi and write this as minus 4 pi log of cosine of pi over 4 minus log of cosine of 0. All right, tangent of 0 is 0. tangent of pi over 4 from special triangles is just 1. Cosine of pi over 4 is adjacent over hypotenuse is 1 over root 2. And cos of 0 is 1. So we have to memorize all of these. All right, so now let's simplify this further. We get volume is equal to pi times tangent of pi over 4 minus pi over 4 minus tangent of 0, which is of course 0, minus 0, minus 4 pi times log of cosine of pi over 4 is 1 over root 2, and minus log of cos of 0, which is 1, and log of 1 is of course 0. So when we simplify this, we get volume, and tangent of pi over 4 of course is 1, so we get volume is equal to pi times 1 gives us pi, minus pi times pi over 4 gives us pi squared over 4, minus 4 pi times log of 1 over root 2, distributing minus 4 pi here, minus 4 pi times log of 1 over root 2, and then plus 4 pi log of 1, but of course we know log of 1 is just 0. So the final answer is volume is equal to pi minus pi squared over 4 minus 4 pi log of 1 over root 2. If we decimalize this, we will get approximately 5.03 for the volume of revolution. Let's go over some of the basic skills that we've applied. So tangent of 0 is 0. We have to memorize this. Tangent of 45 degrees, tangent of pi over 4 is 1. That comes from the 45, 45, 90 triangle. Similarly, cosine of pi over 4 is 1 over root 2. Log of 1 is equal to 0. E to the 0 is 1. Log of e is 1. We didn't apply log e equals 1 in this question, but it's just good to memorize that. And cos of 0 is equal to 1. 1 plus tan, trig identity, 1 plus tan squared y is equal to secant squared y. All right, thanks.